So the subject I'm going to cover next is kind of putting some of the things we have done in the previous videos all kind of together and add a little bit of extra logic in some scripts to achieve what I call walking over some uneven surface. So when you have a character, if it's walking on a flat surface, it's pretty straightforward. But if it's walking over an uneven surface, you could just make him go up and down. But what you really want to do is have them change their angle to match the surface that they're walking on. And in this little demonstration that I'm going to show you, I have some spiders that are all walking over an uneven surface. So if we watch, all the spiders are going to come out of some spot in the back. Their eyes are unlit, as we covered in the previous video, so they always show up, those little red glowing eyes. And each one is going to follow the contours of the surface that they're walking over to make it a bit more realistic. And you can get a kind of a cool effect, and especially with something low to the ground, it really, you can really see how they're following the contours, and they're also walking around some of the taller objects. So what we're going to do for this video is go over all the steps, all the pieces that I put together in order to achieve what we just saw there. So let's get started. So the first thing we're going to look at is to make a couple of assets in Blender. And so in order to really go through the steps of getting a script together to make the spider walk up and over and follow a contour is just to make a basic plane. So what I'm going to do is I'm going to come in here, I'm going to delete this, I'm going to add a plane, I'm going to hit 7 to get an overview. And what I want is I want a plane so that it is kind of known size. So I look at each one of these squares as a square meter. So what I'm going to do is go into edit mode. I'm going to scale this by 20. So now essentially we have a plane that's 40 by 40. Each one of these is 20 in each quadrant. And then what I'm going to do is I'm going to subdivide this. I'm going to come down here by 20. So now actually what we have is each one of those squares is now actually 4 square meters. So we basically have a plane with subdivided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, it's 20 by 20. And what we're going to do is we're going to bring that into a Unity project. The other thing we need is our spider. Now, I'm not going to go over making the spider. That's a video all in of itself, but I have put together videos on creating armatures and drawing characters in Blender and mapping those armatures to the character. And that's just what I have here. You can see we have our armature pieces here. We have a basic spider. It's nothing too fancy. They're going to be pretty small. And what I've done is I have 2 different materials. I have one material for the whole spider. Then if we select the eye, is going to be the red material. And again, I've put together videos on pulling these into Unity, and we're going to have to map the Unity materials onto these 2 types of materials. And I wanted to make the eyes a different material type because they're going to be that unlit red that we had, so they show up even though they're in the dark to give a kind of that cool look. And the last thing is we have our rock formation. So I've made this before. Again, my previous videos just went over kind of how to put together low poly rock formations. In this case, I wanted it's fairly evenly. I think I might have put a mesh over this one to give more even look. Again, what I'm looking for is something that we can see each kind of face that they're walking over, again, in a low poly way. So these are assets that I'm going to bring into Unity. And so what we're going to do is we're going to go over to Unity next and start putting these together, and then start getting our spider to be walking across that plane. So before we start writing the script, what we want to do is think about what it is we want the script to do to move our spider over an uneven surface and change its angle. So this is very important that a lot of people, they jump right into coding before kind of going through and figuring out what it is they want that code to do. And so I made this picture. We got our spider and we have a basic plane. It's got a little hill here. And these two red lines here, this one indicates the normal of one of our polygon faces that we're going to want to align to. The other one is the normal of our spider, basically the spider object. You can think of it as a box around the object, kind of parallel to the top of his body here. And what we're going to want to do is calculate the angle between this normal, and then rotate him, right, to align the normal of our spider object with the normal of the plane he's over. The other thing we need to do is we need to move him up and down. And I've tried this with gravity and collision boxes, and one, it's expensive. Collisions are expensive in Unity. You really shouldn't use them unless you have to. And two, it just doesn't work well with a collision box and the collision plane. So instead, what we can do is we can measure the distance between the bottom of his body here and the surface that he happens to be over at the time. And then what we want is the bottom of his legs to meet that surface. So then we just have to measure the distance from the bottom of his body to the bottom of his leg. And if we know those distances, we can adjust the Y position of our spider to be on the plane, and then he will move up and down as he moves up and like over this hill. So that's what we want the script to do. That's what you have to have in your head before we start trying to implement those pieces. So let's take a look at the code and start writing some script to make that happen. So what we have here is our basic Unity project. And I brought in those assets that I went over that I made in Blender. I've done videos on how to bring those in. I've also done videos on how to bring in a object with an animation and an aperture, and basically hook up the animator in order to run the animation that we want. So what we have is we have our spider, and that spider has an armature, and we can see all the bones in the armature here, and that's important because we're going to be referencing those in our script. We have an animator, and it's pretty simple. Basically, we have one animation. Well, we have two. One where the spider is just sitting still, and one where the spider's actually walking. So what's going to happen is this entry is just when the spider appears and starts running, it's going to automatically just start him walking. And you can see the walking is just, I'm going to execute, the motion is going to be my walking animation. And I'll put links in. I have videos on how to hook all this up and make armatures in Blender and bring it in. So you can take a look at that. I'll put the link in the description if you want more details on exactly how to make this all work. So what's going to happen is the spider's just going to start walking. And if we look at the spider, what we have is we've attached a script onto here. And as you see, the script has one variable in it that we can adjust the run speed, and we'll look at that in a minute. It has an animator connected to it with our Spider controller and our Spider avatar. Again, reference those other videos on how to get this all set up, because that's a video in and of itself. So we have our Spider, and in this case I just put it on here, and I put him well above the plane so we can see how the code does to actually align him on the plane correctly. So let's take a look at that script to see how we're going to do that. So here's the script that we're going to be looking at. You can see that it's called Spider Controller. Usually we always name the script name the same as the class name. And I'm using Visual Studio 2022 Community Edition, which of course is free under certain conditions if you're just a single developer. And what we have here is we have our script. We have the first serialized field. So again, this run speed, by making a serialized field tag, then it'll show up in our Unity editor, and it's going to be a float because we're going to want to be able to adjust it by more than integer values. We have this leg distance, and you'll see what that leg distance is going to hold. It's going to basically be the distance from the bottom of his body, or the center of the object actually, and the bottom of his leg, basically the foot. And what we want to do is we have to do two things. One, we're going to move the Spider forward, because remember, the animation is just going to move his legs, and we have to move him forward so that the speed of his legs matches his forward motion. There's a bunch of things we can do to slow down the animation and speed it up. We're not going to go into those details. Again, I have other videos that kind of go over the details of animation control, and I really dive deep into that. But in this case, we're just going to adjust his forward speed to match the animation speed using this run speed variable. And so what the first thing we're going to do is when it starts, right, start is called first, we are going to grab the armature, and we're going to find the armature named armature 001. And if we go back to this, we can see that's this name here. Armature 001 is the armature, and it's going to have all these bones as part of it. So we grab armature 1, and what we're going to want to do is find the target that is the bottom of his foot. That's this ik target f.l. And if we go back to our Spider in Blender, we can see that's this bone here. So I've selected this bone here at which is the bottom of his foot. So that controls, as this moves forward, his whole leg moves forward. That's kind of what's controlling his leg movement. And if we look at the name here, we can see the name is ik target f.l. So that's really the bottom of his left foot. We could have grabbed any of his feet. I just chose this one to use for the bottom of his foot. So we have that. We have the leg, what I call leg, which is actually foot. And what we're going to do is find the leg distance is going to be the distance, the position y. Remember, y is up and down, minus the leg position. So we're going to, the transform position.y is that's whatever center point we used for the Spider object is what transform position y is. And when we move it around, that is going to be the XYZ value of where the Spider lands in 3D space. So we subtract that from the leg position, so then we get this leg distance. So now we know the distance from the Spider position to the bottom of its leg. And so what we're going to do is we have two other functions here that are important. One is update and one is fixed update. So update runs as fast as possible depending on what else is going on in your scene. And you don't know really how fast or slow it's going. It can vary. And we can do anything. We can change the position of anything in that update. And we use update for that. And in this case, I'm going to transform his position, the position of the spider, by transform direction. So transform direction essentially will use whatever point it's facing toward, it will use that as the XYZ. So it'll align the XYZ to whatever position he's facing. So if he rotated 90 degrees, and is pointing in the Z direction, then now forward is now the Z direction. So we always want to use transform direction when moving things. We're going to make a new vector, and we don't want to change his X or Y position. We just want to change his Z position, because Y is up, X is, say, to the left, Z is always forward. And we can see that quickly by seeing this, right? Here's our X, this is our Y, our Z is forward. And we always want to make sure to draw him and import him so that Z is forward. We don't want him rotated or anything. And this is what we want. And again, I've gone over that in some of my other videos on making sure that Z is forward of whatever object we're moving. So that's going to make him run forward. And then what we're going to do is we need to find the distance between the spider object and the plane or the face that he is over. And we have to use this fixed update for that. And fixed update needs to be used anytime you're using the physics engine. So the physics engine runs at a different speed, meaning it's going to check the physical properties, collisions, and everything on a different cadence or a different speed as update. And you can change this through the settings, edit settings time in your project, but it defaults to 50, which means 50 times a second it is going to be running this fixed update. And you have to do any physics stuff inside this fixed update, or else it won't work. It'll work oddly. So what we're going to use is this raycast. So you can imagine raycast is going to draw a ray or a vector in a direction, which is what a ray is, and it's going to tell us what it collides with. So we use the physics engine raycast. And what we're going to do is we want to cast a ray from the X position. And in this case, it's going to look ahead or up from its X position. And then it's going to point down. And then it's going to check the hit of what we did. And it's going to go forever until it hits something. So let's look back at our drawing. So essentially, it's going to start a ray somewhere up here, right? Five units above the object, and it's going to come down until it hits something. So in this case, what it's going to hit is the plane. Whatever point is directly under the center of the spider is what it's going to run into. So it would run into this item. So if we look at our Unity, it's going to hit the plane directly under the spider here. So it's going to come down and hit whatever point is under him. And then what we're going to do is it's going to, if it didn't hit the spider, and if you had a collision box around the spider, it would hit the spider first. I don't have one right now, but that's what this conditional would say is I don't want to collide with the spider. If I didn't collide with the spider, then what it's going to do is it's going to grab the position is going to be the position of the hit point Y, the Y value of what it hit. And I want to add the leg distance to that. So I want to come up from that point by that leg distance, and then I want to use just the exact same X and Z. I don't want to change the X and the Z, so I just use its transform position X and transform position Z, and then I'm going to adjust the Y. So let's make sure you can visualize this. It's going to come down, it's going to strike this point here, and we don't want to put the center of the spider at that point, right? Or else the spider is going to be like submerged into the plane. We want to subtract the distance from the bottom of his leg to that point of the spider, and that's going to put his leg right on that plane. So what we can do is we can run this, and I've aligned the camera to our scene view here, and we can see he dropped down because it adjusted that Y value, and he's on that plane, and he's executing the animation correctly, and he's moving forward. Now you can see that it looks like he's moving forward, but his legs are like just scraping along because the alignment or the speed of his walking is not matching the speed of his animation. So what we can do is we can change that run speed. Let's change it to 3, just a guess. Let's stop this. Oops. Let's change it to 3. That looks pretty good. Let's try 4. Stop that again. So if we change it while it's running, it doesn't save it. If we change it now while it's not running, it will use this each time. So it's kind of handy while it's moving to modify this. All right, so that's pretty good. I mean, it's not perfect. We can mess with that, but it's good enough for our demonstration here. So what we've shown now is that we have him moving correctly and adjusting the Y position. So now let's put a hill in to see what happens. To that position to see if he moves up and down. So I brought my plane in that we showed with the little hill from Blender. I also made an adjustment because the first plane just had one face in it, but this plane I broke it up into multiple faces because each face has to have its own normal, and so I had to adjust the material. So this brown rect, I had it tiling for 2020. Now it's just 1-1. So basically each face has its own material with a box, brown with the white rectangle around it. So if we run here, let's see what happens. Switch to the scenes, we can rotate. And we see he did not adjust his position. He's just kind of walking right through the hill. So why didn't that work? So let's take a look at our plane. So we have this box collider, and you'll notice that before, when the plane was flat, the box collider was fine because a box is going to be a flat box. This green line indicates the collider. And so that raycast, it doesn't know about this mesh, it just knows about colliders. And so right now we can't use a box collider for that. So what we're going to do is we're going to remove this component. We're going to add physics, and instead of a box collider, we're going to use a mesh collider. So now when we look at our plane, the collider is going to follow each contour of the mesh correctly. So now let's run our animation to see how it works. We can see he is properly following the contours. He's not rotating, but he actually followed the contour correctly because, again, this mesh collider is going to follow that hill. So that's what we need to use for that. So we have our spider moving forward, he's moving up and down, but he's not yet rotating to match the plane that he's part of. So let's take a look back at our script and figure that out. And one note is that it's going to start, we're going to dive into some rotations, and rotations are complicated. Again, I did 3 different videos on rotations and understanding rotations and how to use rotations. So this is using all that at knowledge. And again, it's hard. It's hard to wrap your head around if you're frustrated and just really confused by rotations. Again, I'll put the links to those videos in because you really have to visualize what's going on. And it took me a while. And so I did those videos and didn't get a lot of views. But if you really want to understand rotations, take a look at those videos after you go through this one to really understand what's going on. So we're going to try to take it step by step, but some of the material is kind of complicated. So now we're back into our script code in Visual Studio, and we're going to look at how to align the normal, basically the rotation of our spider, to match the normal rotation of the face that we happen to be over. And we're going to do this we're not going to set the angles directly. What we're going to do is we are going to do a kind of a slower rotation transform. So we'll look through what this is going to take. So at the root of this, what we have in our fixed update is we've added these 2 lines of code. And so the first one is this quaternion. We're going to make a new quaternion, and we are going to make this be basically the angle between the hit normal. So remember, the hit is the face that we ran into, that we were using right up here for our distance to move the spider down. And we're going to look at its normal, and we want to find the difference between its normal and the up vector. And remember that picture that we showed, we have the normal of the face and we have the normal of that up vector. Let's just take a quick look at that. So if we zoom in here, remember this is the normal of our face. The up vector is going to be up like this. So this angle is going to be this angle between these 2. And really it's the same angle, assuming that the spider was sitting over a flat plane, as the difference between its normal and the face normal. So that's really what we're getting there. And it's important that you be able to understand exactly the normal that we're getting. So we're going to get this rotation. And quaternions can be used for basically doing, you can think of it as angle math. So a couple of weird things about angle math is multiplying angles together is the same as adding them together. So when we see a multiply or subtract, or divide, we can think of that as adding and subtracting angles. That's kind of how the quaternion works. And so we get this new rotation. And then what we want to do is we want to move from our current rotation of the spider to the new rotation. So we could just set the new transform rotation exactly equal to the new rotation, but we don't want to do that. We want to kind of transition it, or else it'll be kind of jerky. As soon as it goes over another one, it would snap into position, and we don't want that. We want to make it look a little smoother. And so I made this function start rotation. It takes a start angle and an end angle right here. And so what I have is I have a flag that says, am I doing a rotation? So we set that to true. We set our start angle to the new quaternion. And the quaternions take 3 or 4. It takes the X, Y, Z angle and this start angle W. And again, there's a whole, if there's videos on how all this works, you don't need to understand the details exactly, except that this represents an angle. And the end angle is going to be this end angle that we passed in, and its rotation step is going to be 0. So the question is how many rotation steps do we want to take between the start and end angle? Basically, how smooth do you want it to be? If it takes too long, then, and the spider's moving over a rough surface, he's always going to be behind, because by the time his angle changes, he's going to be over a different face. So we don't want to make it too slow, but we don't want to make it too fast either, which is why we're going to be using a fixed item for that rotation step. So we start the step at 0. And then we come up here and we see in the update what there is there's this added code here, this smooth rotation code. So if we're doing the rotation, that flag is true, then we're going to check the current rotation step if it's greater than 1, because whenever we do a transition, it's always going to be going from 0 to 1. Something's going to be going from 0 to 1. And in this case, our steps are going to increment by this step amount, right? This rotation step amount times our delta time. Pretty standard. So if it's greater than 1, then we're going to start rotation. We're going to set it to false. We're basically going to stop rotating. Assuming we are rotating, we're going to do a quaternion slurp. And remember, and again, if you look at my other rotation videos, I show exactly what this is in detail and how it works. But basically, it's going to compute a new angle based on this rotation step. And if rotation step is 0, the angle is going to be the start angle. If it's 1, it's going to be the end angle. If it's something in between, like 0.5, it's going to be halfway between the start and end angle. So it's going to move from the start angle to the end angle as this goes from 0 to 1. And then we're going to set our transform of our object, basically our spider, to match that rotation. Then it's going to increase that rotation step. So each time through the update, it's going to zip through, and it's going to be transforming from the start angle to the end angle. So that is pretty much it to get our spider to rotate. So now let's take a look at that in action. There we go. So we have our spider. We have our little hill. So before he moved up, but he didn't rotate. So now he should move up and he should rotate to match the angle of the face he's over. He drops down. He goes in. You'll see his head kind of collided with it, but you can see now he's walking and rotating correctly as he should be. And if we select the spider, we can see we have this rotation step amount. If we set it, let's see if we set it to 1, what that's going to do, it's going to change the speed of that rotation. And we see that how it's slow, his rotation, he's barely keeping up. So that's like way too slow. If we set it really high, we can see what happens. This is basically the speed that is going to move between 0 and 1. So you see it's how he like just snaps into place, because it's hardly taking any time at all in order to do that, to move between that 0 and 1 rotation. So we can see we can play around with this. Again, 5 seems to be a pretty good number in order to get him to rotate fast enough without really jerking into place. And again, as you see the whole animation come together, you can play around with those values. So what I'm going to do is I'm going to end this video here. Again, rotations are pretty complicated. The next set of rotations is even a bit more complicated. So I want to take the appropriate amount of time without making this video too long. But we've achieved some pretty good basics. We got our spider moving. He's aligning with the face he's over. So now in my next video, I'll go through basically how to avoid going up and over anything. So if I made this almost straight up and down, he would go straight up and then over and down. And we don't want to do that. We don't want him walking over tall mountains. We want him walking around things instead of just over. And then as he walks around it, we want him to eventually achieve at a set location. So this is kind of doing what the Unity has as part of its AI. It can plot a path around objects to a set location. So this is kind of doing it yourself in code. And in this case, we want them to be some randomness. What I don't like about using that other one, which is fine for some games, but in this case, all of our spiders would be aligned in a line. They would all follow the exact same path. And I want the paths to be a bit more random, to spread out, and to achieve our effect of all those spiders walking kind of over uneven surfaces, kind of en masse toward a given target. So my next video will go through the details. Again, a lot more rotations, a lot more calculations to achieve that effect. So hope you enjoyed this. Again, these rotations are hard. Refer to my other videos on all these steps if you need to. And stay tuned for my next video. Thanks.